The following video covers tools and materials that you'll want for your do-it-yourself builds. The first thing you'll want is a pair of side cutters, a smaller pair for doing work in fine confined spaces, and a larger pair for cutting things like cables that have multiple wires in them. You'll want a 20 to 32 gauge pair of wire strippers. You want a tweezer kit. They generally go for around $10 to $15 on Amazon and will have around 10 to 12 tweezers in them. They're very useful for working in fine spaces, picking up screws, bending wires, and whatnot. Solder, I recommend 63% tin to 37% lead, especially if you're new to do-it-yourself builds and have never soldered before. That is not RoHS compliant. If you do a lot of builds or you're doing something commercial, you will need to convert to RoHS compliant, but the lead-free solder is harder to work with, so this is a good option when you're just starting. A lead bender, it just makes it so much easier and more consistent, and your work looks neater if you use a lead bender to bend the leads of your components. A solder wick is just basically a high conductive braid. If you make a mistake and get a blob of solder on your PC board, you just put the wick on it, heat it up with your iron, and it'll suck it right up. Speaking of sucking, a solder sucker. If you get a blob of solder in the hole of the PC board, a soldering wick won't do the trick. You'll need a solder sucker to get that out. Electrical tape, it's useful for many things. A flux pen, it's not necessarily needed for the microphone parts kits, but I have used it with other DIY kits. Flux basically makes solder flow more freely around a component. You want a toothbrush and an electronics cleaner. You can buy a purpose-built electronics cleaner, or you can get 99% isopropyl alcohol. Do not get anything lower than that. Do not get the stuff that you buy in the local drugstore. It will not work, and it may even damage your components. You'll want acrylic conformal coating by MG Chemicals. That will be for coating the high impedance circuit in the microphone parts kits. I would also recommend a fine paintbrush like the type you'd use for watercoloring, as the brush that comes in the MG Chemicals bottle is kind of blunt and you can't really use it in fine spaces. A jeweler's headband magnifier, they run around $25 and keeps your hands free and just makes things much more easier to see when you're working on small parts. A digital multimeter, the flux-impregnated is kind of the industry standard, but they start at $372. An alternative to that is the Unity UT139C. It goes for $45 on Amazon, and it'll do the trick. Alligator clips, again, something to free your hands, especially if you're building something like the microphone parts S387, where you need to adjust the voltage on one of the pots. It allows you to clip your ground to the chassis and have one hand free for the screwdriver and the other hand free for the positive lead. A third hand basically just holds your PC board, and you can position it how you'd like, and it makes it much easier to work with things. Soldering iron, I bought a Hakko FX888D myself. They go for around $100 to $125. They're great little irons, and they are temperature controlled, and they do have memories in them as well. You will want to get, if you get the Hakko, a T18-D08 chisel tip. The tip that comes with it is rather blunt, and it doesn't hold solder as well as the chisel tip does, and this tip is easier to work with on smaller components. Just a fan, any type of low output fan is fine. I just feather the area I'm soldering with the wind, and that blows the fumes away. And finally, you'll want an anti-static mat and ESD bracelet. NASA argues that these products don't actually do what they say they do, and I have no reason to not believe them. But one of the nice things about these mats, they run about $60 and they're generally blue, is that it makes components so much easier to see if you drop a screw or a resistor or something. It just makes it much easier to find than if you're trying to pick that up off of a brown or a black desk. And also it provides some traction for the components. So with that said, let's move on to the build. Hello, my name is Joe, and I'll be walking you through the build of a microphoneparts.com T47 large diaphragm condenser microphone. The T47 I am building in this video is the microphone that was used to record this voiceover. Your kit will contain the microphone body, a mic clip, the T84 circuit kit, and the RK47 capsule. Inside the T84 circuit kit, you will find a bag of resistors, capacitors, and a diode, a bag with a JFET and 2 custom chosen bias resistors, 2 circuit boards, a transformer, machine screws, nylon tie wraps, and finally, a really well-written manual. As of December 2018, page 4 of the manual has an inventory of the T84 kit. Double check that you have all the parts before you begin the build. While it's probably not necessary with a new board from the factory, I do like to give them a thorough cleaning before I get started. Spray each side of the board with your electronics cleaner and brush with a toothbrush. I'm using a clean, lint-free cloth to wipe off any excess residue afterwards. This is an empty board. You'll notice all of the holes are labeled. Labels beginning with an R will be a resistor, labels beginning with a C will be capacitors, and labels beginning with a D will be diodes. This kit is a relatively simple build, so we don't have to worry about polarized capacitors. Diodes, however, must be installed in a specific orientation or your project will not work. We'll cover this later. When stuffing the board, we will stuff and solder the parts in a specific order, starting with the lower profile parts such as resistors and diodes, and then moving on to the higher profile parts such as capacitors and transistors. The values of some resistors are indicated by colored bands on the part, while other resistors are indicated by writing on the part itself. When working with resistors that have writing on the part itself, when you bend the leads, please make sure to bend the leads so that the value faces up, and when you stuff the board, make sure all values are oriented in a consistent manner so that they can be easily read. Notice how you can clearly see the value of the component when stuffed in the board. Now we're going to stuff the rest of the resistors. The symbol that looks like a horseshoe stands for ohms, which is the unit of measure that resistors are expressed in. M indicates 1 million, K indicates 1,000. The resistor placed in R1 would be read as 10 megaohms or 10 million ohms, and the resistor placed in R6 would be read as 56.2 kiloohms or 56,200 ohms. Note that the 10 megaohm resistor in your kit could either be red or blue. Some photos in the manual that came with the kit show red parts and some show blue. Notice how the leads are all at a 90-degree angle to the board. Do not bend components like this to get them to stay in the board, as it can make extracting the component extremely difficult if you make a mistake, and it is considered bad form. Now it's time to solder the resistors in place. Using a 63% tin to 37% lead solder, heat your iron to 610 degrees Fahrenheit. For the sake of filming, I'm using a third hand, but it may be easier to do your soldering by taking the board out of your third hand and working directly from your bench. To flip the board without losing the components, get a small, thin piece of cardboard, place it over the resistors to hold them in place, and while holding the cardboard in place, flip it upside down. Place the board on your workbench and then remove the cardboard. Apply a small amount of solder to the tip of your iron, touch the tip as close to the lead and the pad as you can, and feed in more solder as needed. Do not feed in too much solder. A good solder joint will envelop the lead and have a concave surface that looks somewhat like a Hershey's Kiss. Once you're done soldering, use your angled cutters to trim the leads and then clean the board. Now we will install the 24-volt Zener diode labeled 1N5252 at D1 on the board, making sure the part number is easily visible when installed. Diodes only allow current to flow in one direction, which means they must be installed in the proper orientation. The diode itself will have a band on the end indicating the cathode. The board also has a band. Make sure that the band on the board and the band on the diode are in the same orientation when the diode is installed. Solder the diode and trim the leads. Now bend pins 4 and 6 on both switches like this. After you've bent the pins, place them on the board with the switch facing towards the long dimension of the board and then solder only one pin from each switch. Inspect both switches and make sure they are flush. If not, apply pressure to the switch and briefly touch your iron to the pin you soldered until you feel the switch move, then immediately remove the iron. Inspect the switch again to make sure it's now flush. Once the switches are flush, you can proceed to solder the rest of the switch leads and then trim them. On the pattern switch labeled card for cardioid and omni for omni, trim off the protruding pins. Do not trim the wrong switch. On the pad switch, bend the protruding pins at a 90-degree angle. Trim off some of the excess as shown. Install and solder the 0.022 microfarad ceramic capacitors, which will be labeled 223J in positions C7 and C12. Trim all 4 leads when done. Now we need to bend pin 3 of the J305 JFET. The JFET will be contained in a separate bag with 2 resistors. Pin 3 will be the rightmost pin when the flat part of the JFET with the label on it is facing you. Grab pin 3 with a pair of needle nose pliers and then bend it at a 90-degree angle away from the flat surface of the JFET as shown. Install the JFET near the pad switch. Make sure the shape of the JFET lines up with the silk screen on the board. Solder JFET pins 1 and 2 below the board, again using a thin piece of cardboard to flip the board, and then trim the 2 pins when done. Do not solder pin 3 above the board. Bend JFET pin 3 so that it touches pin 4 of the pad switch. This is a high impedance circuit and the joint must be formed above the circuit board. Double check to make sure it is not touching the board. Trim pin 3 of the JFET, but do not solder the joint yet. The next step is to choose a bias resistor. Microphone Parts selects the value of the bias resistor to work best with the JFET included in your kit. As such, the value you see in this video and the value included in your kit may be different. There are 2 resistors included in the package, and the value written on the sheet of paper is the one selected to deliver the lowest distortion signal with the highest headroom. Microphone Parts recommends using this resistor. The second resistor included has a value that is about 400 ohms higher than the value written on the sheet of paper. If you install this resistor instead, it will add 10 to 12 decibels of second harmonic distortion with no increase in third harmonic distortion. You might want to choose this value if you're looking to color moderate SPL sources such as vocals, but if you're not sure, use the value written on the piece of paper. Bend one leg of your bias resistor at 180 degrees so the lead from one side is parallel with the unbent lead from the other. Solder the bias resistor into position R3 and trim the leads when you're done. Solder the 1G or 1 gigaohm resistor, which is marked with brown, black, gray, and gold bands, to the pad at R2. Note that if you're in the habit of double-checking resistor values with your digital multimeter, the top limit for most meters is 50 to 60 megaohms, which means you won't be able to measure this resistor. Since you can't use the cardboard trick to flip the board for soldering, you can use a piece of electrical tape or blue painter's tape to hold the components in place. When soldered, trim the lead from the bottom of the board, then bend the top lead to intersect with pin 4 of the pad switch and pin 3 of the JFET. I found a pair of flat-tipped tweezers to be helpful as it's a small area to work in. Again, this joint needs to float above the board and should not touch the board or the bodies of other components. Trim the lead when finished, but do not solder this joint yet. Find the 300 volt 15 picofarad silver mica capacitor, which is marked 15J, and bend one leg so that it is perpendicular to the other. While the manual suggests soldering this cap to C9 at this point, I found it easier to first form the other lead to intersect with pin 6 of the pad switch and solder that first. For clarity, pin 6 is the pin that is closest to the edge of the board. Like pin 4, the connection from pin 6 to the capacitor must also float above the board and not touch the surface, or it could result in signal degradation when the pad is engaged. Once both leads of the cap are soldered, trim the leads. Find the 3 picofarad capacitor marked 3P, which will be installed into C2, and bend one leg so that it is perpendicular to the other. Bend the lead on top so that it intersects with pin 4 of the pad switch, which is the innermost lead that also intersects with the JFET and R2. Solder the cap from the bottom of the board and trim the lead, but do not solder the joint on top yet. Remember, this joint must float above the circuit board. My apologies as the board went out of frame, but you can still see my thought process. Go slow and be patient with this portion of the build. Let's install the red WIMA capacitors now. There are 5 in total. Find the 2 smaller 0.1 microfarad capacitors and place them in positions C6 and C10. Since other components are a little taller and the leads on the WIMA caps are short, I used a piece of electrical tape to hold them in place. Solder only 1 pin on each cap and then inspect them to make sure they're flush with the circuit board. If not, you can use the trick we used earlier with the switches by applying pressure to the part while touching the soldered lead long enough to melt it so you can move the part. Once it moves, immediately remove the iron. Reinspect and then solder the other leads. After you've finished, repeat this process with the larger 4.7 microfarad capacitors which go into positions C3, C5, and C8. It's especially important to make sure these larger capacitors are flush, otherwise they could touch the body of the mic. While the leads on these caps are shorter, they should still be trimmed on the back of the board when you're finished. Finally, the last part to install on this board is the 1 microfarad sonacap. Bend the leads and install the cap at C4. Make sure the cap is flush against the circuit board before soldering it in place. Solder the leads and then double check the part is flush with the board. If it is, trim the leads. With the exception of soldering the high impedance circuit, which we'll do after the capsule is installed, we're done with the main audio board. Now is a good time to go back and inspect the board. Double check all the components and make sure they're installed in the correct locations. Is the JFET oriented correctly? Is the diode oriented correctly? Inspect all the solder joints and make sure they look good. You'll notice that I touched up one spot that I wasn't happy with. After you've completed a review, clean the back of the board thoroughly to remove all residue. To mount the transformer, thread the gray and pink transformer wires through the large hole in the second circuit board with the wires facing the narrow end of the board. Insert one of the provided cable ties from the back of the board through one of the slots near the transformer laminations and tighten the cable so that the transformer is held snug against the circuit board. I used a pair of needle nose pliers to make it easier. Repeat this process with the second cable tie and then trim the ends of the ties. Trim all transformer wires to a length of 3 inches and then strip 5 to 8 millimeters of insulation from each wire. When you're done, tin the bare wire ends by applying a small amount of solder to them. Tinning wires makes it much easier to solder 2 wires together or to solder a wire into a circuit board. Grab the microphone body and open it up by unscrewing the bottom of the chassis near the XLR connector. A few notes for orientation. Pin 3, which is the bottom pin in the XLR connector, is always going to be furthest away from the front of the mic. The front of this body is indicated by a cardioid pattern printed towards the bottom of the head basket. To remove the grill, unscrew the 3 screws holding it to the chassis frame. Microphone Parts notes that the hardware from the factory isn't the best, and the heads can strip easily. If you're having trouble removing the screws, you can get them started by gripping the screw head with a pair of fine angle cutters as seen in the beginning of this clip. Throw out these screws and use the replacement screws provided when reassembling the head basket. Note the tab in the chassis plate. When reassembling, align the cardioid pattern on top of the grill to match with this tab. Remove the capsule from its protective case. Go slow and be patient as it's very delicate. You can gently tap the box on your workbench, but make sure that the surface is spotless beforehand. I found the wider capsule saddle, which is provided in the kit, to be a little easier to work with than the stock saddle, so I opted to replace it. Line up 2 of the screw holes on the saddle with the screw holes of the capsule, and using the smaller of the screws provided, mount the capsule to the saddle. Take your time and be patient as to avoid any contact with the membranes of the diaphragm. Under no circumstances should you ever get a screwdriver or anything else anywhere near the center terminal of the diaphragm. Using the small short screw, attach the blue backplane wire to the backplane of the capsule. Now we will route the capsule wires. On the bottom of the metal plate and on the same side as pin 3 of the XLR, which is usually the opposite side of the tab on the metal plate, label the left hole R for the rear and the right hole F for front. Route the white wire from the capsule that's on the opposite side of pin 3, which is usually the same side as the tab, through the hole that you labeled F. This is the wire for the front of the mic. Again, for clarity, the front of the mic is the side that is opposite pin 3 of the XLR and usually on the same side of the tab on the round metal plate. Route the other white wire through the hole labeled R and route the blue backplane wire through the closest hole on the front of the mic. With the capsule wires routed, you can now reinstall the head basket. Remember, don't use the screws that you initially removed. Use the replacement screws that came with the kit. The cardioid pattern on the grill should be oriented opposite of pin 3 in the XLR. Let's mount the audio circuit board to the front side of the mic chassis. Remember, the front will be indicated by the cardioid pattern printed on the head basket and opposite pin 3 on the XLR connector. Before connecting the diaphragm, first tin the leads of the white front and rear diaphragm wires by applying a little solder to the bare wire. You shouldn't have to strip the insulation as it will have come stripped from the factory. Orient the microphone so that the front is facing down and you can see the back of the audio board. Insert the white wire for the rear diaphragm into the pad labeled RD. Since the space is tight on the top of the board, we will solder this connection from the bottom on the same side the wire is inserted. When you're finished with the rear diaphragm, insert the white wire for the front diaphragm into the remaining pad next to the rear diaphragm, which is the one further away from the edge of the board, and solder it in place. This is the trickiest part of the build. Trim the blue backplate wire. It should be long enough to reach the 4-way junction of C2, R2, JFET, and the pad switch with an additional 2 to 3 centimeters of slack. Once trimmed, strip 5 millimeters of insulation off the end and tin the lead. Wedge the bare wire amongst the other 4 component leads in this joint. If you can find a spot where you can wedge the wire in and get it to stay put, you're ahead of the game. For my build, I ended up fashioning a hook so I could grab a lead in the joint. Make sure that it's snug enough that it won't pop free when you touch it with the tip of your iron. When ready, solder this joint using enough solder to encompass all 4 component legs and the capsule wire. Be careful not to touch the components with your iron. If this is your first project, you might want to practice this move with a cold soldering iron. Don't over-solder this joint. When it's done, it might look something like this. Now we're going to clean the high impedance circuit, but first inspect the solder blob and trim any extraneous leads that are sticking out. Then squirt some cleaning solution onto a toothbrush and clean the high impedance circuit. Inspect it closely for stray fibers and remove them with some tweezers. In the next step, we're going to solder the XLR connector. If you've never worked with XLR connectors before, a common mistake novices make is to reverse the pins when looking at the other side of the connector. If you shine a light into the connector, you will see that the pins are labeled. When in doubt, double check, and when you're sure, double check anyway. You might be tempted to go by the color of the wires you see in this video or in the manual. It would be unwise to assume that consistent colors are always used. Verify first before committing. If the leads of the XLR wires aren't already tinned, tin them first. The pads are labeled XLR1, XLR2, and XLR3. Insert the appropriate wires into the appropriate pad from the bottom of the circuit board and solder them in place. There should be enough room on the top of the board to solder the leads. Trim the leads when done. Are you excited? You're almost done. 4 wires to go. Install the transformer board onto the back of the mic chassis. If the leads of the transformer are not already tinned, tin them now. First, solder the transformer primaries in place. The red wire goes into pad TP1 and the black wire goes into pad TP2. Next, solder the transformer secondaries. The pink wire goes into pad TS1 and the gray wire goes into pad TS2. Trim any excess leads. while you might think it would make sense to test the mic before you put the body sleeve and nut back on, you'll have to wait a bit. These components act as a Faraday cage to shield the capsule and sensitive electronics inside from electromagnetic and radio frequency interference. Without them, you will most likely hear hum. Before closing up the mic, make a final inspection. Are both PCBs installed securely with 2 screws? If not, take care of that now, otherwise the boards may rattle when the mic is placed in front of high SPL sources. Check the orientation of that diode in the JFET one more time. Is the head basket installed securely? If it looks good, slowly slide the body sleeve back on, making sure it clears all of the capacitors and doesn't snag any wires. The groove at the top of the sleeve should seat in towards the front of the mic. After the sleeve is in place, screw the nut back on to secure it. Connect the mic to an audio interface or preamp. First, mute your audio output and then apply phantom power. Allow the microphone to warm up for at least 20 seconds. Slowly add gain to the preamp while monitoring the audio. To test for hum, hold the mic by only the grill, then the body, then by the XLR jack. If you hear hum, it means the body is not making bare metal contact with the grill or chassis. For information on troubleshooting, as of December 2018, you can consult page 23 of the manual that came with your T47. If the mic passes the hum test, mute the audio and turn off phantom power. Open the mic back up and engage the pad, close it back up, apply phantom power, and unmute the audio. Depending on the position it was in, you should either gain or lose 10 dB of output. Repeat the process for the pattern switch to test the omni and cardioid patterns. Enjoy your new mic. Now go make some music.